Let's talk about Newton's second law of motion. So, Newton's second law of motion states that for a non-changing mass, an object will speed up or slow down if there is an imbalance of forces. This is this idea was where we get force of net is equal to the mass times acceleration. Now, it's important to note that net force just means to take into account of all the forces acting on a system. Or in other words, what are all the forces acting on a particular object? And this doesn't account for acceleration or velocity, right? We're looking at the forces that are acting on the object in that time stamp. So let's look at an example here. All right, so let's say we have a 20 kilogram mass. So we know that the mass is equal to 20 kilograms. And it says a 20 kilogram mass is allowed to accelerate down a frictionless 15-degree ramp. So we know friction, so we know the force of friction will be zero, right? 0 newtons, because it's frictionless. We're told that it's frictionless. And then we're also told that the ramp is 15 degrees elevated from the horizontal surface. So we know theta, right? So we know it's so this is the surface, right? And we know that the ramp is elevated 15 degrees above the surface. We know this is 15 degrees. All right, so we can begin drawing our forces acting on this mass. So we know that on every object that has mass, there is gravity acting on it. So we can draw a circle on the center of our object and draw an arrow pointing downwards. This is our force of gravity, because gravity pulls things down, right? Like if the idea where Sir Isaac Newton discovered gravity by an apple falling on his head, right? Because objects fall down, right? So we know we can label this arrow as force of gravity. However, force of gravity can be split up into two parts. So force of gravity can be split up into its perpendicular, and then it's split up into its parallel. So we'll say, imagine a coordinate plane is parallel with the ramp. So here, I'll draw this in red. So let's say we have this right here. Let me do an arrow or a line. Let's say we have a line. This is our x-axis. So from our x-axis, we know that to the left of our axis on our coordinate plane, right? So let's say this is 0, right? We say right here is 0. So the further we get away from 0, we become more negative. While the farther we get from 0, on the right side, we get more positive. So we know if the object is sliding down here, it's going in the positive direction. But if it's going to the left side, it's going to the negative direction. So then with that, let me negative and positive. So we can also draw another part of our axis. We can give it another dimension. And this is where we get our y-axis. So here, wait, let me... we'll try to make it... Okay. Right, so then similar to our y-axis, right, the higher we go up, and then this is not 0. This part is not 0, but this part is 0. So, excuse me, this part is 0. This part is not 0. So this is 0, right? And the farther we go above it, the more positive we are, right? While the lower we get from 0 or from the origin on a coordinate plane, the more negative we can get, right? That's just how a coordinate plane is, right? So we can label these forces. So when you have an object standing still on a certain platform, let's say a table, right? Or in this case, the ramp. The ramp is exerting a normal force on the object to be able to support it. Because if there's no normal force, then the object would just completely be sunk and then the force of gravity would attract it. But because we know there's a force of gravity that's withstanding it and preventing the object from falling, this is known as our force of normal. And then we know, as we said, that force of gravity can be split up into two parts. That is our perpendicular force of gravity and then our parallel force of gravity. So perpendicular force of gravity makes a perpendicular angle with the ramp. So this is, as we said, this is the ramp. And we can see that here is a 90-degree angle. Same with here. This is a 90-degree angle. So this would be our force of gravity perpendicular. So I'm going to do like an upside down T to make sure it's perpendicular. And then we also have our parallel force. So oftentimes you'll see parallel force of gravity be written in two ways. It can either be written down here or it can be written down here to demonstrate that this is our parallel force. But either way, they both mean parallel force of gravity. I personally like to write it here just because it's much easier to like visualize and see that the parallel force of gravity is actually pushing the object down. So we can see force of gravity parallel. Right. So if we know that the mass is 20 kilograms, we can find out our force of gravity by multiplying 20 kilograms by 9.8 newtons per kilogram, which, let's see what we get. 20 times 9.81. We should get our force of gravity is going to be 196.2 newtons. And for this question, we're told to find what is the acceleration of the block down the ramp. So to find the acceleration, right? So as we've learned from Newton's second law of motion, where force of net is equal to mass times acceleration. So we have to find a way to be able to separate acceleration. So what forces are acting on this? So we can see that there's these types of forces, right? So we can either take into account, or we should take into account the normal force and our force of gravity. However, we know these forces are balanced because remember, if they were not balanced, the object would either, if force of gravity and perpendicular was greater than, then the force of gravity would attract it, right? But because we have the normal force is equal to the force of gravity perpendicular, it's able to withstand and hold that force. So therefore, we know that these forces are equal. So if we were to take into these balanced forces, right, our normal force and our force of gravity, right, look at what direction this force is pulling the object, while this one is pulling it upwards, right? So this is pulling up and this is pulling down. So we can say, for instance, we can say this is pulling down the object. Our force of gravity perpendicular is pulling the object 200 newtons down. Well, because we know our normal force will have to be equal, right? It has to. It always has to. It will be equal. Then it will have to be 200 newtons positive. So when we take that into account for our force of newtons, they'll just cancel out. And we'll have zero net force acting on the y-axis. So when we take into consideration about the net force, we don't have to look into the balanced forces because those will just cancel out. Rather, we're looking at the unbalanced forces. So here we see our force of gravity parallel is pulling the object to the right. And there's an unbalanced force because there's no other force pulling the object to the left side. So because we know our total forces that are acting on the object would be our force of normal and our force of gravity perpendicular and our force of gravity parallel, we can write that. So we know that force of net will be equal to our force of normal plus our force of gravity perpendicular plus our force of gravity parallel. But remember how we said force of normal and force of gravity perpendicular are equal, they'll just cancel out. So we don't have to write these at all, right? So when you're taking an actual exam, you don't have to write down the balanced forces. You can just write down the unbalanced forces that are acting on the object. So therefore, we can write this as force of net is equal to force of gravity perpendicular. So now that we know that, we can find our force of gravity parallel. So we know, as I previously mentioned, our force of gravity parallel can be rewritten here or here in the bottom too. Right? It doesn't matter as long as you know that this bottom force is our force of gravity parallel, then you'll be good. Right? So to find this, we're given the angle of theta is 15 degrees. So we know because this is perpendicular, right? We said this angle is perpendicular. This whole thing, right? This whole thing is perpendicular, right? We know that this angle, this right here, this angle of this triangle will also be 15 degrees. Right, this will be 15 degrees. We can draw a little line to demonstrate they're congruent, they're equal. Okay, so now that we have our hypotenuse, we found our hypotenuse and we got 196.2 newtons, and we're trying to find one side, and we have a degree, we have an angle. So what could we use? We could use sine, right? Back to our trigonometry, right? We can have sine of 15 degrees is equal to opposite, right? So the opposite of the angle would be our force of gravity parallel over our hypotenuse, which is our force of gravity, right? But we can isolate force of gravity parallel by multiplying both sides by the force of gravity. Force of gravity. So then we know this will cancel out. And then we said our force of gravity is 196.2 newtons times sine of 15 degrees. So then we're left with 50.780 newtons is equal to the force of gravity parallel. Okay, so now that we have a force of gravity parallel, right, we can now find acceleration. So as we previously said, force of net is equal to mass times acceleration, and our force of gravity parallel is 50.780 newtons. To isolate A or isolate our acceleration, we can divide both sides by m, and then we get that the left side will cancel out, the mass will cancel out. So then we're going to be left with acceleration is equal to 50.780 newtons over, remember the mass of the object was 20 kilograms. So let's see what that equals. So then we get acceleration equals 2.539. And remember, use correct units. So when you're accelerating, you're going the velocity per second. So we write this as meters per second or meters per second squared. And that's our answer